Let's talk about simple linear regression. So simple linear regression provides a straight line that best describes the linear relationship between an independent variable and a dependent variable. So before we move along, let's talk about what this even means. You're going to have data with multiple variables, and one variable will be an independent variable. We would put that on the x-axis, and the other variable would be dependent. It would be on the y. Your x variable, your independent variable, is going to affect where your dependent variable lines up. So for example, the amount of time that you spend studying could be an independent variable, and your grade on the next exam is a dependent variable, because studying will affect what your grade will be. Your x affects what your y will become. Which means that using a regression allows us to use past data to predict future results. And so that's why this is used in a variety of industries, is because they can look back to how they did last month or last year, and they can use that data, run a regression, and it can help them predict what they will be able to do next month or next year. And they do that by using a regression equation like this. Now, this is really no different than the equation of a line that you learned about in your math classes. We just have a few different ways of showing these variables. So that first one there, we refer to that as y hat. So the y with that little up arrow above it is y hat. And that's your predicted value of y. Because what you would do with an equation like this is you would just plug in values for x. You would plug in 10, 15, 20, and it would shoot back a predicted value of y, which is how we would be able to then predict our future results. Now b sub 0, that's your y-intercept of the regression line. Right? Every line would eventually cross over your y-axis. Your b sub 0 here tells you where that's happening. B sub 1 is your slope. So that will tell you whether it's a positive or a negative slope and just how steep this regression line would be. And then x is just your independent variable. X is where we would plug in the 10, the 15, the 20. That's the piece that would change, that would allow you to then predict different values of y. Now, one of the most important pieces that go along with a regression is your coefficient of determination. And this will tell you just how good of a fit your regression line is for your data set. So the textbook definition is that the coefficient of determination measures the percent change in y that can be explained by a change in x. So this value will be anywhere between 0 and 1, or 0 and 100%. We want it to be as close to 100% as possible. Now, you're probably not going to get it to be 100%, because that would mean that each of your data points is directly on your regression line. And that's just not going to be how it happens. But if we get a coefficient of determination that's maybe 90%, we're going to be pretty happy with that. But if we get a coefficient of determination that's down in the 30%, 40% range, that might not be a regression equation that we would want to use to predict future results.